Right, now let's look at question number 21. So here in this triangle, the point S is on PQ, so that the ratio of the length of PS to SQ is 2 to 3. Point T is on SR, so that the area of PTR is 20 and the area of triangle STQ is 18. So what is the area of the big triangle PQR? Okay, so for this question to solve it, we need some kind of understanding of triangle with equal height. So here is what it means. For example, if I have these two triangles laid out in this way, and you will notice that they have different base, but they have the same height. This is the perpendicular height for both triangles. So now if the ratio of their base, let's say is 3 to 2 in this case, then for their area, if you do the ratio, for the area of the left triangle, you would do half times the base times the height, the perpendicular height. And 2, on the right triangle, you have half as well, and then the base is 2 parts, and then the height is the same height as well. So for the half, that can be cancelled. For the that can be cancelled as well, and for the parts it's the same thing. So that means for the ratio of the area of the two triangles, that's equal to the ratio of their base. Okay, so using that we can solve this question. So here we don't know anything, but we do know that for this pair of triangles they have the same perpendicular height. For this pair of triangle we have the same perpendicular height. However, with the larger triangle there are some missing parts that we don't know, so we can start working with the bottom triangle. So with the bottom triangle on the right, we know it's 18, and on the left, we don't know, but we know the ratio of the area of them is equal to the ratio of the base, which is 2 to 3. So in this case, if 18 is 3 parts, then how many is 2 parts? 12. Okay, so now we know that for the area of triangle PTS, that is equal to 18 divided by 3 times 2, that is 12. Okay, so once you know this is 12, you will have some information about the left top triangle. So for the area of the triangle RPS, it would then be the sum of 20 and 12, and that would be 32. Now, if you look at the taller triangle, you will see that, okay, they have the same height, therefore the ratio of this area to this area is equal to 2 to 3 as well. So if you want to find out the total area, you can just do 32 divided by 2 to get each part, and that's 5 parts in total. And then you multiply 2 plus 3. Okay, so that can give you 16 times 5, and that will give you 80 straight away for the area of triangle PRQ. And of course, you can find out the other triangles and do it step by step, but C is the answer. Nice. Now let's look at question 22. So here the diagram shows a plan of a town with various bus stops. There are 4 bus routes in the town, and route 1 goes like this, it's 7 kilometers long, and route 2 goes in this way and it's 12 kilometers long. And route 3 goes this way, enclosing every kind of side. It's like the perimeter of the whole shape, and it is 20 kilometers long. And route 4 goes this kind of smaller rectangle. So we want to find out how long is route 4. So for this question, you can't see that. Okay, so for route 1 is like this rectangle, and for route 2 it's this rectangle, and for route 3 it actually encloses all the kind of side that's exposed to air. So if you try to walk it, you will notice that, okay, it's going through this side, 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 and this side. You will see that it actually covers most of the routes of route 1 and 2. But something is not covered. What's not covered? That is the little rectangle that we're looking at here. And that is actually just route 4. So by analyzing, you will see that route 1 and 2 would add up to route 3 and 4. The sum of route 1 and 2 is equal to route 3 and 4. So they are equal. That means if you want to find out route 4, you can just find the sum, the kind of shared fixed sum, which is 12 plus 17, and then you take away the root of route 3. And then that will give you 29, take away 20, and that is just 9 kilometers. Okay, so that's this question. And now let's look at question number 23. So here I have 3 friends, Miss Raja, Omar, and BT. They all live in the same street. So they are a doctor, an engineer, and a musician in some order. And we know the youngest one, the doctor, does not have a brother. And Miss Bitty is older than the engineer and is married to Miss Oma's brother. What are the names in order of the doctor and engineer? This is like a logical deduction question. what you can do is you can write down the initial of the name to represent the people. So I have Roger, Omar, and BT. So for their occupation, they are doctor, engineer, and musician. So we know that Miss BT is older than the engineer who is married. We know the youngest one is the doctor, and it doesn't have a brother. So if Miss BT is married to Miss Omar's brother, that means Miss Omar has a brother. That means Omar will not be the doctor that we're talking about. And we also know the doctor is the youngest one. If Miss BT is older than someone else, then Miss BT will not be the doctor either. So that means what's left for Roger is just the doctor position. So Roger will be the doctor. And also we know that Miss BT is older than the engineer. That means Miss BT is herself is not an engineer. If Miss BT is not an engineer, then out of the three occupations, what's left for Miss BT is just the musician. So that means BT is the musician. And now what's left for Miss Omar is just the only one left, that's the engineer. Okay, so now if you want to find the name in order of the doctor and engineer, they are the Roger and Omar, so A is the answer here. Now let's look at question number 24. So in the sum, each letters represent a different digit, and what is the answer to the subtraction? Everyone, here's a mistake, but it's subtraction on your book. Okay, so again, different digit is like from 0 to 9, so you can choose from 10 kind of digit, and they're all different. So if we look at the addition, we will see that, okay, so both column would add up to O. So is it possible that there's no carryover at all? No, because if no carryover, that means N plus A is equal to O, and A plus G is also equal to O. And A, they are the same thing. So if you cancel them, that means N is equal to G. But N cannot be equal to G as they're all different digits. Okay, so that means there has to be at least one carryover happening. So let's look at the first column and see whether the kind of carryover happens here. So let's say if it doesn't happen here, you would have N plus A is exactly equal to O. And if it doesn't happen, that means the carryover will happen over here because, again, here's K, here's L. You also have to make it different as well. So A plus G is then equal to a carryover of 1. That means it's more than 10. So 10 plus, that's that O. So is that possible? So you will see that if you replace the O, you can have A plus G is equal to 10 plus N plus A. That means if you cancel the A, G is equal to 10 plus N. Is it possible? No, because they're all single digit. So it is impossible for N and A to not have any carryover. So if it is impossible, that means N plus A will have to have a carryover of 1 because they're all single digit. The kind of carryover you can have is only 1. Okay, and if there's a carryover 1, that means for the value, you have like O plus 10. So that's a sum of N plus A. And now with A plus G, so you can have A plus G plus 1 this time, but is that only equal to O? Not really, because again, as we said, so they are different. So you have to carry another 1 to make them kind of different. So that means AG1, there is also a carryover. So that's equal to O plus 10 as well. So that means these two things are equal. That is N plus A is equal to A plus G plus 1. So if A are equal, that will leave you with N is equal to G plus 1. That means N is 1 greater than G. And now if we look at the last column, we have to deal with the first two columns. For the last column, as we said, that K and R are different. So with a carryover of 1, you would have R is equal to K plus 1. Okay, so this is the relationship we can find. We don't get any exact value, but we don't need them because with the subtraction, you have Rn subtract Kg. So Rn, they are the larger number, and they are always 1 more than the bottom one. So N is 1 greater than G, R is 1 greater than K. So when you do the subtraction, of course, here we'll give you 1, here we'll also give you 1. So 11 is the answer here. Hope it makes sense. Now let's look at the last question. It's a very nice one. Here, what is the largest number of digits that can be erased from the 1000 digit number 2018, 2018 all the way to 2018, so that the sum of the remaining digit is 2018? So let's see what is going on here. So first of all, if you want to erase something so that the sum of the remaining digit change, you can first find out what is the sum of the digit for this original number. So as it's a 1,000 digit number and all the numbers are like 2018 in a group of 4, so you can find how many 2018 are there. Then you can just do 1,000 divided by 4, and that can give you 250. That means there are 250 groups of 2018s. Okay, so now for one group of them, the value of the digit is like 2 plus 1 plus 0 plus 8, and that is 11. And for 250, lots of them, that will give you a value of 2,750. So that is the sum. So what is happening to this question is that you're going to erase some digit so that for the sum of the digit, it can go from 2750 to 2018. So now let's see what's the sum of the value of the digit that we need to erase. So if you do the subtraction, you will have 733. So that means the mission for us is to erase as many digits as possible so that what's being erased, their sum would add up to 732. So I hope this question makes sense so far for everyone. So that's the first step. Find out how many, what's the sum do you need to erase. And now let's try to erase them. So here, the condition, there are lots of combinations that can give us 732, but we're restricted to find the largest number of digits that we can erase. So I want everyone to think, if you want to erase as many digits as possible, but the sum of the digit is fixed, then out of 2018, which one do you want to go first? Yes, 0, because erasing 0 would not like make any difference, but that can add up to the, that can make the number of digits that you erase very big. So let's erase 0. But with the 0, you can only erase 250 of them. And still we haven't kind of managed to reduce the sum. So that means we have to erase some digit with actual value. So what's the next one? 1, very good. You start with the second smallest one. So if you do 1, how many 1 can you erase? Again, there are 250 number of 1s that you can do. And with those 1s, it's contributing as in you can kind of contribute to the 732 with 250 times 1. So that's a value it can contribute. And that will leave you with a value of 482. So that means we still need to erase something so that the sum of the erased number are 482. So after dealing with 1, which one do you want to go first? 2 or 8? With 8, with very few 8, you can reach this goal, but we want to erase as many digits as possible. So we want to go to the third smallest one, which is 2. So with the 2s, again, we know there are 250 groups, so there are 250 number of 2s. With that, that can give you 500. So that means we can kind of achieve our goal with just erasing 2s. But how many 2s are we going to erase? You can just do 482 divided by 2, and that can give you 241. Okay, so that means for the final step, we are going to erase 241 lots of 2s. So these are the total number of digits that we erase. And that's maximum that we can do because we're always dealing with the smaller ones. So if you add them up, that's going to give you 741. So 741 is the answer for this question. Okay, hope it makes sense for everyone.